Okay, now this is chapter 6, standardization. All right, first we will talk about converting raw scores to z-scores. We discussed this previously, but let's refresh our memory. So there's a formula for z-score is z equals to x, which is a score, minus the mean, and then divided by standard deviation, right? Or if we are talking about big population, like all SAT takers in the nation, then it's a score x minus mu, which is population's mean, and then divided by sigma, which is population's standard deviation. Yeah, as we said. All right. So the process of converting a score, a raw scores to z-score is called standardization. All right. Now, standardization can be applied to a lot of situations like real life. So I'm going to give you the example. So suppose Ruby and James take statistics from different teachers. Ruby got 90 out of 100 in her first exam, and the mean standard deviation for the whole class is 70 and 10. Now, James got 42 out of 50. The whole class mean is 35 and 7. Question is who did better? Yeah, we know this is two different systems, but actually we can convert it to z-score and compare which one do better. All right. So the thing you do will be converting their scores to those raw scores, 90 and 42, to z-scores, and then we compare the z-score. So for Ruby, it's her score 90 minus the mean, which is 70 in her class, and then divided by 10, and the answer is 2. For James, it's 42, his score, minus 35, the class's mean, and then divided by 7, which is 1. All right. Now, right now, it's clear who did better. Actually, it's Ruby. Look at this distribution, okay? When we convert all the raw score into z-scores, then the z-scores distribute like this, with smaller values on the left and a bigger value on the right. Now, in this case, a bigger value implied higher scores. So z-score 2 right here is bigger than z-score 1 right here. That's why Ruby did better. Right?